Hi, it's Kevin Lobates here. So I was thinking the other day, with all this discussion about random numbers on blockchains for a proof of stake, that I haven't actually talked about what randomness really is. Maybe it's, as a mathematician, I'm taking it for granted. So I thought it would be a good idea to have a little video explaining what random, pseudo-random, predictable, and entropy are all about. So if you have a deterministic system, then it's not going to be truly random. I mean, that sort of speaks for itself. It's deterministic. That's the opposite of random. And because computers and blockchains are deterministic systems, in that we know what an output is going to be given a particular input, in order to create randomness, you need to have some kind of external input to provide that randomness. And this is the issue that proof-of-stake blockchain systems are dealing with. In a proof-of-work system, the randomness is provided by all these miners that you don't fully know about participating in the system. In proof-of-stake, you don't have those miners, you need to get the randomness from somewhere else. So this is where we hit some issues with randomness, because it's not quite as straightforward as it seems. For something to be truly random, this means that you cannot predict beforehand what the outcome is going to be, like a roulette table. If you could predict where the little ball was going to fall, then casinos wouldn't be operating with them. Then there's a second thing that we want in randomness in this particular case, which is uniform distribution. And a uniform distribution of results means that each result is equally likely. And this, for example, is why casinos get inspected regularly by a gaming commission of some kind to ensure that their roulette tables are not tilted and biased so that, say, the number 0 or 00 comes up more often or something like that, because that would be cheating the punters. So again, for our random number on the blockchain, we need to know that every number is equally likely. And so now I thought I'd talk a bit about pseudo-random number generators. So a pseudo-random number generator is a deterministic algorithm, which means that given a particular input, you can calculate the output, and it's the same every time you calculate it, but it outputs a stream of numbers that look random. They are uniformly distributed with no bias towards them, and for all intents and purposes, they look to the human eye like they've been created by a roulette table or the rolling of a fair die or something like that. But they are deterministic, and typically a pseudo-random number generator takes as its input something called a seed, which is a starting value, and often you use something like the timestamp of the computer at the point that you run the pseudo-random number generator. But the fact is that if you know the seed that was used to seed the pseudo-random number generator, you can generate the same numbers. And if this pseudo-random number generator is being used to generate a new random number every minute, then what you can do is you can work out where you are in the sequence and predict what the future numbers are going to be. And obviously that's not going to be good from a gambling perspective or from a selecting the next block minter on a proof-of-stake blockchain perspective. So in order to get this randomness into the blockchain system, you need some kind of natural process. I read a paper where they're using a video stream of some footage from a camera pointing at a natural phenomenon like a tree waving around or cloud formations or something like that, things that you can't game, in order to get the seed for generating random numbers, and they change that seed regularly. So that's one way of doing it. Another way, which is what Ethereum is doing, is you get a whole bunch of different participants to create their random number by whatever means, and you munge them all together with this XOR operation. And the idea there is that if just one of those participants has generated a truly random number, then the output of that process will be truly random too. But you see, you've always got this problem of externalities. Now, of course, if there was a suitable, trustworthy random number generator authority out there that you could rely on 100%, then you could just use that. But that kind of goes against the whole idea of blockchain, which is meant to be distributed and decentralized, and there isn't meant to be a central authority, certainly not a central random number generating authority. So that's the problem that they're going to try and overcome with the beacon chain in Ethereum. And I did say I was going to talk a bit about entropy. So it has one meaning in physics. It has a slightly different meaning in computer science and information theory. Entropy is a measure of the true randomness of a system. And the idea is that something that has high entropy is, for all intents and purposes, random, and something that has low entropy is a predictable deterministic system. And the way that that works is there's actually a formula related to it, and it is based on the idea that the less random something is, the shorter the amount of data you need to provide in order to be able to create the whole stream of random, or supposedly random, or the sequence of numbers. So, for example, a sequence of 10 ones, 1,111,111,111,111, that number can be represented much quicker just by saying 10 ones, and that therefore has a low entropy because you don't actually need to send that number that I just said. What you can just do is say, write down 10 ones, and you've got the number. Whereas if we took another totally higgledy-piggledy one, I don't know, 7,345,519,744, that one, you may not be able to compress it into a shorter way of expressing it. And if you have to provide the entire number in order to be able to transmit it, rather than some kind of compression, then you have a very random output, and that has a very high entropy. So when we talk about a source of entropy, that is what we kind of mean by the randomness of the system. If you can get a high source of entropy, maybe it's listening to fan noises, or a resistor that's a thermistor that's generating sort of fuzzy output that's unpredictable, that's a good source of entropy. Means you can create good sets of random numbers, whereas something like a regular pulse would be a very bad source of entropy because it's very predictable, and therefore the level of randomness in the system will be lower. So there you go, a ramble about randomness. Hope you found that interesting, and that it gave you a little bit of a deeper insight into what I'm talking about when I'm looking at randomness here in blockchain systems. And I'll see you in the next video soon. Bye for now.